started on this. I wouldn't even know where to begin. Listen up. Eleanor.
I said yes.
You had to be distance because
Distance also.
when you're doing
Guys, listen up.
traveled, it's never going to go back down. So it couldn't be any of the other ones because your distance is never negative.
Okay, that's actually a good point on the choice of word that they use. That's not a position graph.
Right, it's just distance.
Okay.
Yeah.
Okay, so then you started with this. How did anyone else start? How did you start this? Lauren.
I started backwards actually with acceleration,
Okay, then what did you do then?
and then I maxed out the graphs accordingly. Like
So let's start here. Well, what do you think is what?
2 is B, 1 is C, and
2.
3 is
Okay, 2 is your velocity, you're saying? So this is your velocity. What's your distance equation?
I mean 2C.
Okay.
Wait, 2 is acceleration.
Okay, 2, you're saying this is acceleration.
Yes.
And then what's this one?
Velocity.
And then this is distance?
Yes.
Okay, sorry, how many people agree with that? Any disagreements? I saw about 3 hands that disagree or indifferent. Does everyone agree? No one disagrees? Okay, let's see your reasoning. Take me through it.
If you have acceleration, I figured that was acceleration because it went up and down, and you can, so it's negative and positive. So
Okay.
you look either.
Always?
No, but because it goes under the x-axis, it's negative. So it starts off positive, then goes negative, which means it switches. The velocity switches. So you start off and then you start slowing down.
Okay.
So that would be velocity. And if you, for a position graph, it wouldn't look like it would still be a line. So for position, you have the only one left. And also because it accelerates, and then you start slowing down, and then you come to a stop. Well, you come to a stop.
Okay, so were you getting information off of the acceleration graph off of this, did I hear you say?
What? No, I worked backwards.
I thought I said, did you say something about acceleration off this, or what did you say about this one? Maybe it was
Oh,
the
I
choice
said
of word
because
that you used.
Because
Because you actually can, we just haven't gotten to it yet. You can
Yes,
actually get
because
information
so-
about acceleration off this graph, we just haven't talked about it yet.
Well, yeah, because you start accelerating up, and then you slow down.
How do you know that? What are you looking at?
Because the distance graph. Well, the distance graph is because you start going, and then you come to a stop because it's a straight line. You slow down when you pass the hump.
But you're talking about velocity.
Yeah, and then for acceleration, it's, yeah.
Sonia.
I thought 3 was the distance graph, so it goes.
So you started with the distance graph?
Yeah.
Did anyone else start with distance, or did you start with acceleration?
I started with distance.
Okay. How many people started with distance? Any other, just kind of work your way down?
I did start with
About 3 people. What else did everyone start with? Just start guessing? You start with velocity. Okay, I'm gonna start with the distance. I want to hear about that. Go ahead.
So, isn't like the derivative of the position graph was the distance against that velocity, and the derivative of that would be acceleration?
Is it? So let's go. Is that right? Like derivative of position or whatever this is should be velocity. The rate of change of what you're traveling, the distance traveled, and then the rate of change of that would be acceleration. Do we all agree with that? Okay.
Is it?
That's what they're saying.
Okay. But like I know it's harder to do relate the distance graph with the acceleration. So once I used it first to get the velocity graph because that was easier. So I said that was like.
So how did you get this as the derivative of this? Like how do you know that?
So at first it's like slow and it's speeding up, so it's going up, and then it's slowing down. So the slope of the tangent lines are getting less steep. So.
Okay, but like, give me just the sign then. I think you're already going like already into almost acceleration then. But like, what is this thing doing the whole time? It's increasing. You know what I'm saying? It may stop increasing, but it's increasing the entire time, which means the derivative of this graph should look like what? Well, why? Like what's specific? I don't know about the hump and stuff, because you're getting into the hump. Always positive. That much I should know. You know what I'm saying, you guys? Because the humps and stuff, I don't know. Let's get too much into it. But like for me, what I know is if this is increasing, then the derivative of this thing has to stay positive the whole time. Does that make sense? So this could match off of that. And then what happens with this one?
The derivative of that is the acceleration, and we know that it like the tangent line at 1 is about 0 or
Okay.
0.
So what happens before 1?
It's increasing, so
Which means the derivative of that would be
positive.
positive. It should be a positive graph, then a
0,
0, then a...
negative.
Yeah, and does this match up?
Yep.
Again, this has these extra humps and stuff. I'm not sure about those yet, but I know, like, since this thing is always increasing, the derivative has to be positive. Okay, this matches up, you know, and this thing should be positive, 0 and the negative. So this matches up, so that order kind of would work, I guess? Anything else to share about, how did you start with velocity?
Oh, well, I just looked at the first one. And then I was
So
like,
you started here, you just picked one.
yeah, I just
And what did you do with that?
picked one, and then I was like, okay, so slope from 0 to 1 is positive,
Right.
increasing. And I look to the left, and I look at the other graph to see from 0 to 1 what was happening. And I saw that, yeah, they were both increasing. So then I looked at 1, and it was at 0. So then I looked at 2, and then I saw that it was at 0. So I was like, the derivative of the first graph would have to be 2.
Right. And it couldn't be this one, right? Because this thing's always positive.
Yeah.
Okay, cool. And either way, whatever you guys did, what's good is a lot of people, you just start. You know what I'm saying? You just pick one, and then just, what's the derivative going to look like? Does that make sense, you guys? Just get started, because it's kind of overwhelming, like, oh, I can't match it up. Brain overload. But just start with something. Any other comments? Yes, Amino.
Is that usually just a way to tell which one is which? Like, is the distance one usually just like simpler than the other one?
Well, that's interesting. Define simpler. Because actually, there's a lot going on the distance. Because what we're going to get to is, we're going to get information off of both of these off of this. So there actually has to be a lot going on this one. You know what I'm saying? But that being said, it's like, yeah, it just kind of looks like a little squiggle, and then looks like there's more happening here, right? So this one does look simpler. Interesting. Yes?
Well, if number 1 was a distance graph, or the position versus time graph, then the derivative of that would be a straight line crossing,
Derivative, this one?
yeah, wouldn't it? And so, like, actually the velocity, if that was distance, then the velocity time graph would be simpler. So it doesn't...
Well, so here's my only issue with...
Both of it doesn't really matter, right? I mean, like...
We'll get into more like the specifics, you know what I'm saying? I mean, it's good, like this whole idea of like the simpler graph and breaking it down. And would the derivative of this be a straight line? Well, let's think about it this way, you guys.
Like,
What shapes derivatives are straight lines? What family of functions has a derivative of lines?
squares.
Parabolas, yes? So this is close, but it's not, so this isn't going to be total linear, you know what I'm saying? Since this isn't a perfect, because it's got this little wiggle, 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 wiggle,
Oh, yeah.
then it shouldn't be total linear. And again, we're going to be like, well, what should it be then? I don't know. You know, we'll get into that. Does that make sense?
Yeah. What's the
Yeah, and that's what we said, yeah, but it's interesting, like, you know, is that a line, or it kind of has the same overall, like, frozen. It kind of has the same overall, but it has, if it's a parabola's derivative, it is a straight line, and that's what we've been doing. Does that make sense? With anything x squared, 2 to the n. Let's try this one. Seems like we're having fun today. That was your trick. Here's your treat. You see how I tied it in, you guys? Because Halloween was yesterday, so then I said trick or treat. And it's kind of like like Halloween is like you go around trick or treat.
I get it now.
You get it? No, yeah.
Explaining it.
Yeah, you got it. You got it. It was up, yeah. I like to tie things into the real world applications. IMP stuff. All right, answer this question. Let me get this out of the way. So you need your calculators. I want you to put that data into your calculator. How do you put data in your calculator? Great question for the group.